So earlier we saw the relationship between the factors and coefficients of quadratic equation. Now let's see what is the relation between the factors and the coefficients of a cubic equation. Suppose a cubical equation is ax cubed plus bx squared plus cx plus d is equal to 0. Okay, and because it's a cubical equation, at most it can have 3 zeros, and let's assume that these 3 zeros are alpha, beta and gamma. Then the sum of the zeros, basically alpha, beta and gamma, is equal to minus b upon a, which is b a. Sum of the product, taking 2 at a time, taking two zeros at a time, right? So if you'd first take alpha, beta, then you take beta and gamma, then you take alpha and gamma. The sum of the product of 2 zeros taken at a time is equal to c upon a, and the product of the zeros alpha, beta, gamma is equal to minus d upon a, right? Another simpler way of doing these things is that whenever you have something like ax cubed plus bx squared plus cx plus d is equal to 0, what we do is we divide everything by a, right? This gets cancelled and basically you get b upon a, you get c upon a, you get d upon a, right? What you need to be careful about is that here you have a minus b, right? And the coefficients of these numbers are then basically these outputs. Let's look at one example to better understand this thing. So you are told that you have to find out a cubic polynomial with the sum of its zeros. So if it's a cubic polynomial, let alpha, beta and gamma be the zeros. With the sum of its zeros, sum of the products of its zeros taken 2 at a time. So sum of its zeros, sum of the zeros taken 2 at a time, alpha, beta plus beta, gamma plus alpha, gamma. And the product of its zeros, which is alpha, beta, gamma, is equal to 5, minus 6 and 12 respectively, right? So let's call this cubic polynomial as ax cubed plus bx squared plus cx plus d is equal to 0. Or the way we discussed, we just remove this a from here, b upon a, c upon a, d upon a. We divide everything by a, right? Now, we know that alpha plus beta plus gamma is equal to minus b upon a. Can I just plug in this value over here? So I can write this as x squared. This is plus b upon a, right? I have to put in plus b upon a. So minus b upon a is equal to 5, which means plus b upon a is equal to minus 5. You have x cube over here. So I just put in as it is, plus c upon a, right? Now we know that the sum of these two zeros taken together is equal to c upon a, which I just showed you, right? So this c upon a, I can substitute this by minus 6x plus d upon a. The product is equal to d upon a. 12 is equal to 0. So just by applying this particular shortcut formula, I have been able to arrive at the cubic polynomial, wherein all these properties would hold true.